Now let us revise about the preparation and the purification of colloids. Preparation and purification of colloids. Now lyophilic sols are easy to prepare because the dispersed phase has a very strong affinity for the dispersion medium. So we have no special method to prepare lyophilic sols. And most of the methods which we use, they are used only for the preparation of a lyophobic sols. So preparation of lyophobic sols. And the methods can be classified into or divided into two categories. The first one called the chemical methods. Chemical methods. Now these are also called the condensation method because in this case we prepare the colloid from the true solution. So we're increasing the size of the particle. So these methods are also called condensation methods. And there are four methods in this. First one is called the hydrolysis, which is used to prepare a ferric hydroxide sol. So ferric chloride, when added to boiling water, it forms a ferric hydroxide sol plus the 3HCl. This is ferric hydroxide, or we can write the hydrated ferric oxide sol. And this is a wine red color sol. Wine red color. Now second method is called oxidation method, which is mainly used to prepare oxidation method. It's mainly used to prepare the non-metal sols. Used to prepare a non-metal sols. For example, the sulfur sol can be prepared by the oxidation of the H2S gas using atmospheric oxygen. It forms a sulfur sol. This is called sulfur sol. Or we can oxidize the H2S gas using sulfur dioxide or any other oxidizing agent we can use. So it gives a sulfur sol again, plus it gives a water molecule. Now the third method is called reduction, and reduction method is used to prepare the metal sols, but metals with very low chemical reactivity. Used to prepare a metal sols like gold sol, silver sol, metals having low chemical reactivity. For example, this gold chloride can be reduced to gold sol by using stannous chloride. So this is used as a reducing agent. So it forms a red color gold sol, red color gold sol, and this is side product SnCl4. This is a balanced equation. And the fourth method is double displacement or double decomposition reaction. And this method is used to prepare the arsenic sulfide sol. To prepare arsenous sulfide sol. It's a yellow color sol. By passing the H2S gas through arsenous oxide. So we are replacing the oxygen by sulfurs, thereby we are increasing the size of the particle. So this is a yellow color arsenous sulfide sol. So these are condensation method where we are increasing the size of the particle. Now second method to prepare the lyophobic sols are the dispersion method. These are called the physical methods. And these are called dispersion methods, in which we are reducing the size of the particle to make it in the range of 1 to 1000 nanometer. Dispersion methods. And the first one is very, very important, that is called a peptization. Now, peptization is a method to convert the freshly prepared precipitate into particles of colloidal size using a suitable peptizing agent. It is basically an electrolyte, peptizing agent. Now we'll take one example. When we add ferric chloride to this boiling water, initially it gives a reddish brown precipitate of the ferric hydroxide. It's a reddish brown precipitate, and this precipitate is porous, and this precipitate then absorb ferric ions on its surface from the ferric chloride. So this is adsorption of ferric ions, because ferric ions have a size same as the size of the pores, and due to the repulsions between the like ferric ions, the precipitate becomes unstable and break down into colloidal solution and gives a wine red color. So in this case, our peptizing agent is the ferric chloride, wine red color. Now second method in this category is called the Bradig's arc method. Now this method is also used to prepare metal soles. Metal soles, metals with very high melting point. For example, gold sole, silver sole, tungsten sole can be prepared by this method. Now in this case, we take electrodes of the metal whose sole is to be prepared, and these two electrodes are connected to a high tension battery, and these electrodes are in contact with the dispersion medium in a tank surrounded by ice. Now when the voltage is passed, when the high voltage is passed, metal at the tip break down into small pieces and evaporate into small pieces. This is called dispersion, and evaporate. And since the tank is surrounded by ice, these particles immediately condensed into the dispersion medium, and gives a sole. Now this is the diagram involved. This is a tank surrounded by ice. These are ice particles, and these are the two electrodes of a metal connected to a high tension battery, and this is a dispersion medium. Next is the purification of colloids. Purification. Now the 2 points are very important. The first point is that the size of the impurities is less than the size of the colloidal particles, and second point is that these impurities are electrolytic in nature, mean they are charged particles, electrolytic in nature. Now a small amount of the impurities gives stability to the colloid, but excess of impurities makes the colloidal unstable. So we have two very important methods to purify the colloids, and the first method is called a dialysis. Now dialysis means the separation of impurities from the colloidal solution, separation of impurities from the colloidal solution by using a membrane which is permeable only to the impurities. So the membrane allows only the impurities to pass through, while the pure colloidal particles left behind inside the system. So this membrane is called semi-permeable membrane, SPM. And since the impurities are electrolytic in nature, therefore we can speed up the dialysis by applying an electric field. So when we use electric field to speed up the dialysis, then this is called electrodialysis. So impurities from the blood can be separated by using the membrane present in the kidney. So it is used in the separation of impurities from the blood. That is the role of the kidneys from blood in the body. Now second method is this is called ultrafiltration. Now in this method we use ultrafilters which contains pores and allow only the impurities to pass through. These pores, and the pure colloid is left on the paper. And these ultrafilters can be formed by coating the ordinary filter paper filter paper. Ordinary filter paper has a very large pore size which allows the colloidal as well as the impurities both to pass through. So ultrafilters can be formed by coating ordinary filter paper with a collodion. So this collodion helps in reducing the size of the pores. Now collodion is a 4% solution of nitrocellulose in ethanol. That is called collodion, and it is used to reduce the size of the pores so that only the impurities can pass through and not the colloidal solution. So these are the two important methods to purify colloids.